A very good afternoon to one and all. And in today's class, I'm going to explain about the implementation of the three-address code. How the implementation takes place in an three-address code, where this three-address code is one of the form of intermediate code generator. Here we're having three forms of intermediate code generator. That means in three types of representations, we're generating the intermediate code. What the first way is in an abstract syntax tree, and what the second way is in a polish notation. Polish can also be called as in prefix notation. If you are having a question like an reverse polish, then it can be called it as an postfix notation. Make a note of this. Polish notation can be called as an prefix. For example, if the given expression is in the form of an infix, then you need to convert it into an prefix, or sometimes you need to convert it into an postfix. That polish is a prefix notation and reverse polish is a postfix notation. Make a note of this. And then the third way of representing an intermediate code is a three-address code representation. And again, I'm recalling what the definition of the three-address code is, and again I will explain with an example, and I will repeat what the forms of representations in a three-address code instructions. For the three-address code instructions, how we are going to represent, what are the forms that we need to follow when we are representing the language statements. That way I can call it as in translation statements. That means each and every line from the expression where we're generating a translation statement here. Translation statement in the form of an intermediate language. Make a note of this. And here, as already explained what the three address code is, and here in the slide it consisting of a DAG representation, and T1 is equal to B minus C, T2 is equal to A into T1, T3 is equal to A plus T2, T4 is equal to T1 into D, T5 is equal to T3 plus T4. These are all the temporary names that are generated by the compilers. That means it is an intermediate language where it consisting of an translation statements, where each and every line we are calling it as a translation statement. It was stored with a temporary name T1, T2, T3 and so on up to Tn. It depends on the given input string, given input expression. And here again I am defining what the definition of the three address code is. And what the definition of the three address code is, it is the most important definition. The three address code form, at most three addresses are used to represent any statement. That means how we are defining this three address code means the name itself it is there. At most three addresses are used to represent any statement. Here we are representing an intermediate language statements, that is in translation statements, right? So we need to follow the representation of the three address code. That means at most three addresses are used to represent this statement. And here taking an example of statement number 1, where the statement number 1 is T1 is equal to B minus C, right? In the statement number 1, B and C are the operands. That can be of names or constants or anything. And here we're having a temporary. See, T1 is in temporary. That is in compiler generated temporaries. That is in compiler generated temporary. And in between the two operands B and C, we're having an operator. We're having an operator, and that operators can be fixed. We are taking the operators from the given expressions. We are not choosing our own operators, or we are not choosing our own operands, right? From the expression, just we are representing the translation statements just by following the rules. Following the rules or following from the definition of the three address code, we are representing. And here we are following the forms of representation for the three address code instructions. These also can be called as in three address instructions or translation statements. Every line can be called it as an instruction or translation statement. And here the operator, it should not be fixed, or it can be of any type of a floating point or arithmetic operator, or sometimes we can choose an logical operators. That means when we are writing an expression, when we are writing an input expression, there itself we can choose this a floating point operator or an arithmetic or logical or boolean valued operators, boolean valued data. And here one thing we all must understand and should be noticed here is only single operation at the right side of the expression is allowed at a time. Make a note of this. What it means is for every transition statement, that means in every transition statement we need to perform or we need to allow only one operator. one operator. We need to perform or we need to allow only one operator. Not more than one operators are allowed when we are writing the translation statements in an intermediate language based on the forms of 3 address code. Make a note of this, right? And that is the most important thing. Again, I'm repeating, only single operation at the right side of the expression is allowed at a time. And what the T1, T2, T3, T4, T5 are the temporary names that are generated by the compiler. And finally, concluding the introduction or concluding the definition of the 3 address code is with at most 3 addresses are only allowed. Only 2 for operands and 1 for storing the results. 2 for operands and 1 for storing the results. And therefore, we are naming it as the representation as a 3 address code representation. Is it clear now? And if you have the question with an expression, construct a DAG, construct a syntax tree, or whatever it may be, construct something from the given expression. If you are constructing from the given expression, first you need to represent the translation statements for the expression, and then you need to represent either it may be a DAG representation or either it may be a syntax tree. Totally depends on the given question. Is it clear? And these are the forms of 3 address instructions. I already explained in the last class. When we are representing, when we are writing the translation statements from the expression, it may be an infix or postfix or prefix. We need to choose the first 3 formats. We need to choose the first 3 formats. Or if we are having a programming language, from the programming language constructs, if we are having an if conditional statements, for any type of conditional statements, we need to use the next 3 forms of representations. And if you are having any procedural calls from your language construct, that means programming language constructs, then you need to use the paramex call p comma n, y is equal to call p comma n. These are the forms of representing the 3 address instructions. And then representing for the array, then you need to use these forms like x is equal to y of I and x of I is equal to y. And finally, with but here I am having the forms with an ampersand and with an asterisk. What it means is these are using as in pointers. If you want to use for the pointers, these are the representations, forms of representations for the 3 address instructions to represent in such a manner. That means we need to follow the form of representation. Based on following those, we are implementing the translation statements. And this is an example. The next is an example. I already explained this example. And what's today concept is implementation of 3 address code, which is the most important concept in intermediate code generation. Implementation of 3 address code means how many data structures that we are having for implementing the 3 address code. Only 3 data structures we're having here. In that, the first one is in quadruple, the second one is in triple, and the third one is an indirect triple, right? Or explain the implementation of 3 address code. You need to explain quadruple, triple, and indirect triple with an examples just by taking an example statement. If it is given in the question, take that expression and write down the transition statements, and then draw the tables for the quadruples and draw the tables for the triple, and finally for the indirect triple. That's the way of writing the answer for the given question. And how the implementation takes place. What is in quadruple, what is in triple, and what is an indirect triple. Why we are calling these 3 as in data structures of the data structures for 3 address code. Right. Here we're having a question, right? This 3 address code is an abstract form of the intermediate code. Make a note of this. Whatever we are implementing for the 3 address code is an abstract form of the intermediate code that can be implemented as a record with the address fields. And here we are using these 3 as in data structures. These 3 codes, we are calling them as in codes, address codes. 3 address codes as in data structures. And one is in quadruple, and the second is in triple, and the third one is an indirect triple. What is a quadruple? What is a quadruple representation? It is a data structure, right? It is a data structure. Why we are calling it as a data structure? With at most 4 fields, it is defined. With at most 4 fields, the quadruple representation is defined. What those 4 fields are? The first field is an operator, the second is an argument 1, and the third one is an argument 2, and finally the fourth one is an result. These are the 4 fields. With these 4 fields, we are representing a quadruple. And what the operator field is, it is used to represent the internal code of the operator. For any internal code for the operator, we are using OP. And argument 1 and argument 2 represents the 2 operands. And that means for the operator, we are having the left operand and the right operand. The left can be called it as an argument 1 and the right can be called it as an argument 2. Make a note of this. And the result field is used to store the result of an expression. Here we are storing the result in the form of an temporary names, where those are generated by the compilers, right? And clearly, I will show you with the example, the representation of the data structure quadruple. See here. First, from the given example, A is equal to, in the slide there is no A, but write down A is equal to B into minus C plus B into minus C. First, from the given expression, what you all should do is first write down the 3-address code representation for the given expression. That means writing or representing and translation statements for the expression just by using a temporary names T1, T2, T3 and so on. Here from the expression, first initially I need to store this minus C into one temporary variable, and then I need to multiply this temporary with the B, then it is stored in another temporary variable, and again it is on left hand side because M is acting as a mediator between these two parts, left part and the right part. And I will choose from the given expression, I myself will choose, I will make it as an half expression. That is, I am dividing the expression into 2 halves based on the operator, And this plus is acting as an mediator. With the plus, I am dividing the given expression into 2 halves. That means B into minus C is the left hand side part and B into minus C is the right hand side part. And finally, I am, by using the operator of plus, I am merging these 2 left hand side and the right hand side part into a single expression. See how the translation statements are written for this given expression. First I am storing the minus C into a temporary variable T1. See here, T1 is equal to minus C. T1 is equal to minus C. And this minus C is multiple with a B, right? And again, I'm choosing another temporary T2, and that T2 is assigned with B into T1 because it was already in a T1. So B into T1. And half of the part is completed. Now come to this side, right side. Again, T3 is equal to minus C. T3 is equal to minus C. Here I am not implementing any DAG. So don't take the same temporary here. Right. Again, you need to write a new temporary for the minus C because it was already for in an T1. Right. If you eliminate an cycling, if you eliminate an duplicate or duplicate temporaries, then you need to choose the DAG representation. So here we are not implementing any DAG or not constructing any DAGs. Just we are writing the translation statements for the expression, and for each and every sub expression from the expression, right? So T3 is equal to, again it is stored with a minus C, and T4 is equal to, again the B is multiple with a minus C, right? That is B into T3. And this is B into T1 was stored in an T2, B into T3 was stored in an T4 temporary variable. And finally T5 is equal to this one plus this one, that is left hand side part and the right hand side part. This is an T2 and this is an T4. So T5 is equal to T2 plus T4. And this, whatever the resultant that assigned to an T5, it should be in an A. That means A is equal to B into minus C plus B into minus C. So I am assigning this temporary T5 to the A. Make it clear. Because whatever the resultant I am having in the T5 variable, it should be assigned to an A. So this is the way of representing and translation statements for the three address code from the given input expression. This is an input statement or input expression. From this, these are to be written like this, just from the forms of intermediate instructions, three address code instructions. Right? Is it clear up to the writing of the three address code? That means writing the translation statements from the input expression. Then coming to the implementation of the three address code, the first data structure is a quadruple, and we know how the quadruple representation is. It consisting of 4 fields, right? Operator, argument 1, argument 2, and result. And from each and every translation statement, just I am placing the statement into an table. Just I am placing whatever the line statement number 1 consisting of, just I am placing into an table. And into second statement, just I am placing into a table. That's it. I am doing nothing logic is there, nothing syntax is there to be followed, right? This is the main thing. This is the main thing that we need to do after taking the input as an expression and writing the translation statements for the three address code. Then in statement number 1, what the operator I'm having there, minus is an operator, and there I'm not having any operands, only one operand is there. So I'm considering that operand as an argument 1. That is operand 1 is an argument 1 here. And the resultant, this minus is stored in an T1. That means the left hand side parts are acting as an result variables. Whatever the left hand side part consisting of in every translation statement, those comes under the resultant part, resultant field. Make a note of this. And the minus C was stored in an T1, right? So where I'm having, this is the result. 1 I am using for the result. So T1 is an result. C minus C T1. Because in the statement number 1, I am not having any argument 2. So only the argument 1. What argument 1 and argument 2 are nothing but an operands in the statement. Operands in the statement. Make a note of this. That is left operand and right operand for the operator. And T2. This now going for the second statement. My second statement in the RHS I am having 2 operands. That is B. That is in left. Argument 1 is in B. Argument 2 is in T1 and operator is in star. That is star B T1. And where it was storing in an resultant variable T2. T2, right? Is it clear now? Now again T3. Again here the statement consisting of only one operand and one operator. Minus is an operator and C is an operand 1. That is an argument 1. This is storing in the temporary variable T3. That means the resultant is in T3. This is a resultant temporary name. So minus C and the result is in T3. Again coming to the next statement, B into T3. Operator is in star. B is an argument 1. T3 is an argument 2. And the resultant is in T4. Is it clear now? And T5. Next statement. T2 plus T4. That is plus is an operator. T2 is an argument 1. T4 is an argument 2. Resultant is an T5. Right? And A is equal to T5. A is equal to T5 means this, the whatever the computation that we done with T2 and T4 is stored in a temporary name T5, right? And this resultant is assigned to an A. And that's why I am taking the assignment is an operator here. Assignment is an operator here. And in the right hand side, I am having only the operand 1, that consider it as an argument 1. And the resultant is an A. See? Is equal to T5A. Is it clear? Is it clear how to represent the quadruple table? After knowing how many fields the quadrant data structure quadruple, how many fields that the quadruple data structure consisting of? Only 4 fields. Operator, argument 1, argument 2 and result. Right? After by taking the input as an expression and after writing the translation statements like this in a 3 address code format, then it is very easy to write and table representations for the quadruple or triple or indirect triple. Once you write the quadruple from the 3 address code statements means from the quadruple table we are representing an triples, and then from the triple we are representing an indirect triple. Is it clear now? Now what the second data structure is? Second data structure is a triple data structure. That is after knowing the representation of the quadruple, quadruple is a structure with at most 4 fields. And now we need to know about a triple. And here in triple representation, use of temporary variables is avoided. We're avoiding the temporary variables. That is, whatever the result field we're having, that we're avoiding, that we're not representing in the triple table, right? And instead of avoiding the temporary variables, what we're doing here is the temporary variables is avoided just by referring the pointers in the symbol tables. Make a note of this. Just by referring the pointers in the symbol tables, we are implementing the triple representation. See, from the quadruple, just I am writing the triple representation. This resultant, the temporary variables are avoided in triples. Instead of avoiding these temporary variables, just by referring the pointers in the symbol table, just see in the place of T1, T2, T3, here in triple representation, we are not using T1, we are not using the temporary names from by the compilers, right? Instead of these temporary names, what we are using here, referring the pointers in the symbol table, just by giving an sequence numbers, just by giving an numbers. What these numbers means, see here also we're having a statement. We can call them as a statement numbers, not a sequence numbers here. 0, 0, that is statement start 0, 1, 2, 3, 4, 5. Make a note of this. 0, 1, 2, 3, 4, 5. Right? Is it clear? And in the statement number 0, what the resultant it was stored? T1. Make a note. In the statement number 1, what the resultant it is? T2. In the statement number 2, what the resultant it is? T3. In the statement number 3, what the resultant it is? T4. In the statement number 4, what the resultant it is? T5. In the statement number 5, what the resultant it is? A. But here in triples, we are only avoiding the temporary variables, not the variables. Only we are avoiding the temporary variables, right? So how we are writing or how we are representing the triple table means, here we are having only the 3 fields. Triple structure is with, triple is a structure with at most 3 fields. What those 3 fields are? Operator, argument 1 and argument 2. We are not taking the result field here. Result field is eliminated from the quadruples. So what the result field consisting of? All the temporary variables, right? So we are avoiding those temporary variables. Just by referring the pointers in the symbol tables, we are implementing these triples. Make a note. And see, only 3 fields, right? Where we avoid this result field. That means we are not writing this result field. And minus C, say minus C. And star B T1. Instead of T1, instead of writing the T1, the temporaries are avoided here, right? So instead of writing the T1, what I'm writing here? Referring the pointer in the symbol table. What it mean? For the statement number 0, what the resultant it is? T1, right? So I am using, instead of T1, I am using 0. Instead of T1, I am using 0. Right. And minus C, and here B, T3. And the T, it is T3, right? The T3 was stored with an statement number 2, right? So I am using 2. I am using 2 here. And this T2 and T4 plus T2, T4. T2 is stored with a statement number 1 and T4 is stored with a statement number 3. So 1 and 3, right? And only I am avoiding the temporary variables, not the variables, right? So is equal to, instead of T5, now the T5 is in an argument 2 and A becomes an argument 1 because A is a variable. But we are eliminating the temporaries, we are avoiding the temporaries. That means we are not writing a field of a result. So this A is acting as an argument 1 now, and in argument 2 we are having an T5. And the T5 is having a serial number, that means a statement number 4, right? So we are writing the 4. With these references, we are pointing within pointers from the symbol table. Right? Is it clear now how to write the triples? And this is about a triple representation, where triple is one of the second data structure in a 3 address code. And the third one is an indirect triples. Third one is an indirect triples. And here in the indirect triple representation, the listing of triples is being done. Listing of triples is being done. And the listing pointers are used instead of using the statements. What it means is here, the name itself, it says that it is an indirect triple. The same thing we are implementing as it is from the triple. As it is, whatever we represented in a triple, the same thing we are using here. But there in the triple we are using the 3 fields. In the indirect triples also we are using 3 fields. That means operator, argument 1 and argument 2. While coming to the representation of the indirect triple, we are having a separate table representation. What the separate table representation means, what it means is, see, these are the statement numbers. 0, 1, 2, 3, 4, 5 are the statement numbers. Initially in the triple representation, we use these statement numbers, right? These statement numbers are the reference numbers. We used them as an reference numbers. That means we are referring the pointers in the symbol table by using these, right? And for this, I am giving another new reference numbers like 35, 36, 37, 38, 39, 40, or it may be 11, 12, 13, 14, 15, 16, like that. That means I am defining the statement here, statements for the pointers. Make a note of this. Instead of using the statements, what I am doing, I am listing the pointers. That means listing of pointers are used instead of using the statements. That is done in the indirect triples. That what it means is, in an indirect triple, the listing of triples is being done. Whatever we done in an triples, the same thing we are implementing here, but the listing of the triples is being done here. That means here we are representing a separate table like this, and for the statement numbers, where in the representation or where in the implementation of the triple, we used these as an reference numbers for pointing in the symbol table. That is references that pointers in the symbol table, and for this we are giving the new numbers. We are calling them as an reference numbers, new reference numbers. It may be 35, 36, 37, 38, 39, 40, or 10, 11, 12, 13, 14, 15, or 10, 20, 30, 40, as ever wish, as ever wish. Here we are not having any constraints. The numbers should be only these set of numbers only you should use. We're not having the constraints like that, right? So it's our wish to give any number for the 0, to give any number for the 1, to give any number for the 2, and for the 3, 4, and 5, right? And while coming to the representation of the indirect triple table, here instead of 0, we need to use 35. Instead of 0, we need to use 35. Instead of 2, we need to use 37, and 1, 36, and 3, 38, and 4 is 39. And here, whatever the table representation we are having is as it is here. But there is a change. Make a note, all of you. In the place of 0, please write down 35. In the place of 2, write down 37. And in the place of 1, write down 36. In the place of 3, write down 38. And in the place of 4, write down 39. Then it becomes an indirect triples. What it means is, now I am implementing. After representing this, now I need to check it out whether what the sequence number of this, what the reference, what it refers to, what the number refers to. For example, in the place of 0, I'm having 35, right? This is a new reference number for the statement number 0. 35. What the 35 refers to, it points to an statement number 0. What the statement number refers to, it points to an T1. Is it clear now? That is, indirectly we are implementing this just by writing a separate table like this and writing the new reference numbers, just by giving the new reference numbers to the statement numbers. Is it clear now? And this here, when I am checking at the triple representation, and after implementing this, after completing the representation of the triples, now I am checking out, and here I need to refer for the 0. What the 0 is, and 0 is a statement number, what it refers to. And in the quadruple representation, it refers to an T1. That means the resultant under the 0 is an temporary variable T1, right? What the T1 is, minus C, right? Here we are implementing directly. The process is done in a direct manner, but here the process is done in an indirect manner. That means a listing of triples is being done in an indirect triples. Make a note of this. And instead of using the statements, here again we are listing the pointers. Here we are listing the pointers, and those are used for instead of representing the statements, or instead of using the statements. That means I need and 2 in here, that in place of 2 it is in 37, right? And now I am pointing it at 37. What this 37 refers to? Referring the pointer in a symbol table, and in the symbol table what it points to? 2, right? And again it referring the pointer in the symbol table. What is to? What is to? T3. What is to? T3. Is it clear now? That means here we done in a single step process, we are implemented in a single step process, and here we implemented in a 2-step process. Why we are implementing this is, we need to know how the data structures are implemented, what the context of the data structure is, what is the difference in representing of these 3 tables. Here, as starting of the concept of implementation of 3 address code, I started with there are 3 data structures, right? And here we're clearly understanding that how the data structures are represented in a table formats. What the rules that we are following here. And when we are representing the quadruples, what the fields that we need to take here from the translation statements. And for the triples, why we are using these why we are using these pointer representations. So just by avoiding an column like an resultant, where the resultant consisting of all the temporary variables, to avoid the temporaries, just what we are doing, just by referring the pointers in the symbol table, we are using the numbers like this, right? That's the important context that we are having in the triples. That means context means what the meaning of using this triple is. That means while using the quadruple, what is the difference between using of the triple? Is there any advantage in the disadvantage in the quadruple? Then we are using the triple. Here we are not considering all those. Just we need to know how many data structures that consisting of the 3 address code, and what the way of representing those data structures, and what we need to follow to represent these. What is an quadruple and how many fields it consisting of? What is an triples and how many fields it consisting of? And what is the difference between the representing the quadruple and the triple? And what is an indirect triple, and why we are representing this? And in what we are following, what the rules that we are following while representing the table. And now what's the difference between this triple and the indirect triple? Right? Is it clear now? This is the way of writing or constructing or implementing the 3 address code. 3 address code means you need to write all these 3: quadruple, triple, and indirect triple. This is about an implementation of 3 address code. Implementation of 3 address code. And writing a 3 address code for the expression or from the lines of programming language constructs, that is differ from this, right? This is an implementation part, that is just knowing how to write the translation statements based on the forms of 3 address instructions. Make clear of each and every concept. Forms of intermediate code is differ from the implementation of 3 address code. 3 address code is one of the form in an intermediate code generation. Make a note. 3 address code is one of the form in an intermediate code generation. So for this 3 address code, we are implementing, we are learning about the implementation. How the implementation is done in a 3 address code with these 3 data structures. I think you all understand the concept, and you all understand how to represent an quadruple data structure and triple data structure and indirect data structure, indirect triple data structure for the given input statement. Just after taking an input statement, first thing, don't directly go to represent the 3 data structures. First thing is you need to write the 3 address code like this. You need to write the translation statements in a 3 address code format like this. Then only start representing the tables of quadruple, triple, and indirect triple. Is it clear? And note down the question: construct or implement 3 address code for the given expression. Implement 3 address code for the given expression A plus A into B minus C plus B minus C into D. Note down this expression. I need the implementation of 3 address code for this expression for the tomorrow class. A plus A into B minus C plus B minus C into D. After knowing how to implement with the 3 data structures, and take this example and show the implementation for the 3 address code. Is it clear now? Now, after learning the implementation of 3 address code, here where we need to know what the merits and demerits of the quadruples or the triples or the indirect triples, right? And in quadruple representation, we using in temporary names, the entries in the symbol table against those temporaries can be obtained, right? Is it clear now? That means using the temporary names, the entries in the symbol table against those temporaries can be obtained. And here what the advantage with this quadruple representation is, we can quickly access the values of the temporary variables just by using the symbol table. What it means? Use of temporaries always introduces the level of indirection for the use of symbol table in the quadruple representation. And that is the most one of the advantage here, that we can consider it as a merit of the quadruple. And it is also having the benefit, one most important benefit, that is always the quadruple representations is beneficial for code optimization. Make a note of this. Beneficial for code optimization. This is the next phase of the compilation process, right? And after learning or after implementing the intermediate code generation, then we need to implement the code optimization by performing optimization techniques. So this quadruple representation is beneficial for the code optimization. And the next one is in triple. This triple representation, the pointers are used here, and by using the pointers, one can access directly the symbol table entry. One can access directly the symbol table entry. And while coming to the next data structure, that is an indirect triple. Here we are listing out all the references for the computations that is made separately, and whatever the computation that we made separately, that also be stored in a symbol table. So here finally how the concept was concluding is, the indirect triple and the quadruple representations are similar. Both are similar as far as their utility is concerned. And here always the indirect triple saves some amount of space as compared with the quadruple representation. And these are the 3 address codes simplifies the task of generating the actual code. That means we understand, after learning this, we understand that how to obtain the 3 address code for various programming constructs, right? That means it is necessary to understand what are the forms of intermediate codes, various forms of intermediate codes, and what the implementation of the 3 address code is, and what the data structures that are involved in the implementation of the 3 address code. And here in this phase, that is an intermediate code generator, totally we focused on the 3 address code, because the output that looks, or the output that generates from the intermediate code is an intermediate language, where that language consisting of the translation statements, where it was stored with an temporary names, right? T1 is equal to T2 is equal to T3 is equal to, and so on. So, and then after knowing that, after knowing the how to write the translation statements, then we know how to generate the intermediate code for various programming constructs. And this is about the concept of forms of intermediate code and the implementation of the 3 address code. I think you all understand the today's concept about the forms. Forms means I already explained how to draw the syntax tree and how to represent the DAG. And you all know infix to prefix and prefix to postfix conversions, right? Prefix. Here you only, the thing you need to know is Polish notation can be called it as a prefix notation. Reverse Polish notation can be called it as a postfix notation, right? And then the third thing is a 3 address code. 3 address code. These 3 comes under the forms of intermediate code. And the implementation of the 3 address code is differ from the forms of intermediate code. Make a note of this. When coming to the concept of implementation of 3 address code, here we are explaining about the 3 data structures: quadruples, triples, and indirect triples. From the given expression, or by taking our own example, in the form of an expression, we are implementing the 3-address code. We can, because we understand how the implementation takes place. So we can implement by the given example, or by taking our own example, we can show the implementation of the 3-address code, isn't it? Right? In the next class, I will explain about the translation statements and the translation declarations, because in semantic analysis already explained about the type equivalence, type checking, type conversion, type statements. All those concepts are explained at semantic analysis. Now I am not recalling all those, right? And what the next concept is in an intermediate code generator is an translation statements and translation declaration, type declarations and statements. So in the next class, I will explain the concept of type declarations and the statements. I think you all understand the today's session. For the given example, like a plus a into b minus c plus b minus c into d, please all of you implement an 3-address code form. 3-address code form for the given expression.